So nucleophilic substitution reactions is nothing but what? Generally Rx plus nucleophile will get RNU plus X minus. So nucleophile substitution reactions. Nucleophile is substituting here. So nucleophiles, for example, CH3, CH2, Cl. If I am using the OH minus. CH3, CH2, OH plus Cl minus. So particularly this nucleophilic substitution reactions undergoes alkyl halides majorly, along with alkyl halides, somewhat alcohols and ethers also we can see the nucleophilic substitution reaction. The nucleophilic substitution reactions, once again we are going to classify 3 types. SN1, SN2, SN9. So SN1 means what? Unimolecular. So we'll discuss the majorly SN1, SN2 are important. So then SN9. SN1, SN2. SN1 means what? Unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. This is bimolecular nucleophilic substitution. Majorly here 3 degree, then 2 degree, 1 degree alkyl halides will undergo. In this case 1 degree, then 2 degree, then 3 degree alkyl halide. So first we will see the SN1. For example, R1, R2, R3 from X. So it's a chiral center. This is a chiral carbon because 4 different groups. But if I am using any nucleophile, here is for example any nucleophile. So here is the product is R1, R2, R3 nucleophile, R2, R1, R3. If both are 50-50%, we could say this is what, Nana? Racemic mixture. So this is actually exactly the reaction. You see the mechanism here. Or the first step, what exactly happens? The X minus is going on. This is, we could say, slow step, nothing but RDS, rate determining step. So this is basically which hybridization? sp3 tetrahedral shape. Tetrahedral shape. When the X is going out, we'll get the intermediate here. The carbocation is intermediate. So this is sp2 hybridized trigonal planar shape. Trigonal planar. So then the nucleophile can attack from back side or front side. 50-50 chances are there. Front side or back side. So then we'll get this product. This is tetrahedral shape now. Basically. All are in the different direction. This is one direction, this is one direction. Right? So imagine, or we can say, you can take like this also. Anything is fine. Imagine this is a green color one is the nucleus, right? Halogen. So when it is halogen is going out from this one, total nucleophile. So this becomes trigonal planar. This. So this is a trigonal planar means, right, like this. Either it can be like both the cases. So other nucleophile can come from front side or back side like this, right? So 50-50 chances are there. If it is like this, it's coming like. If it is like this, it's coming up, right? So either this side or this direction, trigonal planar. So what is that? Racemic mixture means optical active. When we are passing the plane polarized light, the optical active one is clockwise, one is anti-clockwise. So this is the slow step. In the slow step, only one molecule is participating. So that's why we are called as what? Unimolecular nucleophilic substitution reaction. So here is rate is directly proportional to, right, only alkyl halide, but not nucleophile. This is an important point which we need to understand. Okay. SN1. So this is first order reaction. First order. Carbocation intermediate. Carbocation intermediate. When carbocation intermediate is there, what exactly happens? Rearrangements are possible. And more important thing is rate is directly proportional to stability of carbocation. One more. Stability of carbocation. If the carbocation is more stable, so more faster. Favorable in polar protic solvents. Favorable in polar protic solvents like water. Polarity is there, electronegativity difference is there, and it can give the H+. H+ nothing but polar, favorable in polar protic solvents. The better leaving group is always better. So leaving group stability. Leaving group is inversely proportional to base strength. Base strength, inversely proportional to base strength. Means what? If it is weak base, better leaving group. It's a weak base, better leaving group. How should we know the weak base? Base strength. So for example, try to understand. This is O minus. We imagine both are leaving groups. Both are leaving groups. These both are leaving groups. If it is weak base, that is better leaving group. So weak base, how should we know? Difficult task sometimes. Simply what I am trying to say, add H+ both. Right? So now compare the acidic strength. Which is strong acid? Obviously this is stronger acid. After losing this one, phenoxide ion is having the resonance stabilized. Right? So this is strong acid. Strong acid's conjugate base is what? Weak. Strong acid, its conjugate base is weak. So means simply cross check. Whatever the leaving groups are there in front of us, what we need to do? Add H+, and we need to cross check with the acidic strength. Acidic strength is easy to identify. Once we know the acidic strength, so if it is a strong acid, that is the best leaving group. So remove that H+, that would be the weak base, that would be better leaving group. Got it? So this is the logic, write it down. Next, weak nucleophile is favorable. Weak nucleophile is favorable. Nucleophile is favorable because the nucleophile is coming in the fast step. Weak nucleophile is favorable. So because in the slow step only one molecule is participating, that's why we called as unimolecular. Unimolecular. So SN2, I told you bimolecular nucleophilic substitution. Directly I am giving the Cl, for example, OH minus. This is inversion product. Inversion. Retention and inversion both are there. If the Cl place same position, if it is occupies, that is retention. If it is opposite side, if it is attacking, that we could say inversion. Okay, the mechanism Cl plus OH minus is slow step. Slow step. RDS, rate determining step. The slow step, both molecules are participating. So that's why we could say this is bimolecular nucleophilic substitution. The OH minus is coming from the back end side. So OH this is because it's not intermediate, it's a transition state. Transition state. What is the difference between intermediate and transition state? Transition state means what? No? For example, the compound is like this, right? If something, when other nucleophile is coming, the same simultaneously this is going. If it is strengthening, it's losing. Both are taking place simultaneously. If it is coming now, it's going like. So there is no proper time. But whereas in case of intermediate, it has some stability. The first step OH, H, H, H also. The slow step low, two molecules are participating. That's why we could say bimolecular. Right? It is no carbocation. So no rearrangements. Favorable in polar aprotic solvents. Aprotic solvents, because here is nucleophile also should be more important for us. Strong nucleophile is favorable. Strong nucleophile is favorable. Right? Inversion product. Inversion product is the product. దానికి దీనికి మెయిన్ డిఫరెన్స్ ఏంటి? SN1 కి SN2 కి bulkiness. CH3 for example, C2H5, CH7, Cl. ఇక్కడ OH మైనస్ అనేది ఫర్ ఎగ్జాంపుల్ బ్యాక్ సైడ్ నుంచి అవ్వగలుగుతుంది బికాస్ ఆఫ్ బల్కీ గ్రూప్స్. ఇవి రాలేదు, అప్పుడు ఏంటిది కంపల్సరీ ఇది వెళ్ళిపోవాల్సిందే. ఇది వెళ్ళిపోయినాకనే వస్తుంది, రైట్? అలా జరుగుతుంది. సో మెయిన్ డిఫరెన్స్ వచ్చేసి ఇక్కడ బల్కీనెస్. SN1 ఏమైంది, ఫస్ట్ Cl వెళ్ళిపోతుంది, వెళ్ళిపోయిన తర్వాత కార్బోకేటైన్ వస్తుంది. అంటే మెయిన్ డిఫరెన్స్ ఏంటి? ద బల్కీనెస్ ఇంక్రీజింగ్ దట్ అండర్గోస్ SN1. బల్కీనెస్ లెస్ బల్కీనెస్ దట్ ఈస్ SN2. అందుకోసమని ఇక్కడ 3 డిగ్రీ అని చెప్తాం మనం. ఇక్కడ 1 డిగ్రీ, 2 డిగ్రీ, 3 డిగ్రీ. సో ఇక్కడ ఏంటంటే మెయిన్గా క్వశ్చన్స్ ఎలా అడుగుతారనే దానిపైన మనం ఫోకస్ చేద్దాం. 2-3 మోడల్ క్వశ్చన్స్ చెప్తా, దెన్ ఆఫ్టర్వర్డ్స్ యూ కెన్ ట్రై ఇట్. For example, which is faster in SN1, is faster in SN. So here is weak nucleophile is favorable, but how should we know the weak nucleophile? And this one and this one. So nucleophile కోసం మళ్ళీ strength రాసేసుకోండి. Nucleophile, how to identify the nucleophiles? First, always conjugate base is stronger nucleophile when we compare with its acid. Right? Always conjugate base, it's stronger nucleophile. What is conjugate base? For example, OH minus H2O, right? Both are coming, so which is stronger nucleophile? OH minus. H2S, HS minus. Right? Conjugate base, the first one. Next, nucleophile strength is directly proportional to size of donating atom. For example, OH minus SH minus. Oxygen and sulfur. We know oxygen, sulfur, selenium, tellurium, polonium. Top to bottom, what exactly happens? Size is increasing. So, in this case, which is stronger nucleophile? Obviously, SH. Right? NH2 minus pH. Which one? pH2. For example, chlorine, chlorine, bromine, iodine. Then third point, nucleophile strength is inversely proportional to electronegativity of the donating atom. Right? Same order we can get. More electronegative. The size is more, less electronegative. Obviously, it is coming like that. For example, CH3CH2 minus, CH2 double bond CH minus, C triple bond C minus. Right? Which is stronger? Obviously, this is sp hybridization, percentage of S character directly proportional to electronegativity. So fourth one, nucleophile strength, right, directly proportional to donating groups, electron donating groups, and nucleophile strength is inversely proportional to electron withdrawing groups. Next, last one, nucleophile strength is inversely proportional to crowding at donating atom. Crowding at donating atom. These five are very important. For example, try to understand CH3, CH2, O minus, O minus, O minus. So O minus, which one would be the better in this case? Here is crowding is less, here is somewhat more, here is high. This is better, the fifth one. So electron donating groups, electron withdrawing groups, I think these are the 5 points. So from this only they are asking the questions. Okay. Now in this case, SN1. Same question they'll ask SN2 also. H L OH minus H Cl H minus A and B. SN2. Yeah, tell me, in this case, what is the answer? Which is faster in SN1. A greater than B. Ikkada B greater than. Ikkada manaki 3 points are coming at a time. Nucleophile strength teliyala, SN1 SN2 teliyale, daniki weak strong ga teliyali, appude decide. Direct ga chudangane answer radu. Then koncham practice kavali. Is faster in SN1, SN2. So nucleophile same icha. Nucleophile అయిపోయింది కదా క్వశ్చన్. nucleophile మీద అడుగుతారు, లివింగ్ గ్రూప్ మీద అడుగుతారు, గ్రూప్ మీద అడుగుతారు. Obviously Br- అనేది బెటర్ లివింగ్ గ్రూప్. So B greater than